right, so as we move on talking about acids and bases, we're going to talk about some calculations, and this looks like a lot, but I promise it's not a lot. Kw, hydrogen ion concentration, hydroxide ion concentration, pH, and pOH. So first off, what is Kw? It's called the ion product constant for water. So when we put water in a container, water breaks up into hydrogen and hydroxide ions. 2H's, 1O, 2H's, 1O, right? So we get these ions, and then they form back together to make liquid water, and this process goes back and forth, back and forth. Now, we have what we call an equilibrium constant for this, and the constant is this number right here, 1 times 10 to the negative 14. Now, why that number is important, okay, that's Kw, that's the ion product constant, but most importantly, if I take the concentration and molarity of hydrogen ions and the concentration of molarity of hydroxide ions and multiply them together, it will equal 1 times 10 to the negative 14th if I'm just dealing with water. And this is a huge equation in acid-base chemistry, okay? This multiplying is a constant, okay? So the whole point is that as hydrogen ion concentration increases, then hydroxide ion decreases, and vice versa. If hydroxide increases, hydrogen decreases. But multiplied together will equal Kw, okay? So there's your first fact. Now, there's also the pH scale, and I know you've looked at this in biology and other courses, and it is the concentration of hydrogen ions in a solution. So we're looking at hydrogen ions only. So pH is the negative log of the hydrogen ion concentration, and your calculator does all that, okay? The pH is the negative log of the hydroxide ion concentration. Here's a fact. pH plus pOH equals 14. So this plus this will equal 14. Now, let's say we want to work backwards from pH or pOH to find that concentration. If you do inverse log or base 10 of the negative of what the pH is, that will tell you the concentration of hydrogen, and negative pOH, that's the exponent of your base 10, is the hydroxide ion concentration. And I'll show you how to do those in the calculator when we do the examples. But these equations with the Kw are what we're going to use to solve things. So is something acidic, basic, or neutral? Here's how we know. We look at the pH. If the pH is less than 7, okay, then it is acidic. If the pH is greater than 7, it's basic. And if it's exactly 7, it's neutral. And here's the hydrogen ion concentrations, right? If we take the base 10 log of negative 7, we'll get this. If we take the base 10 log of negative 7, we get this, and the base 10 log of negative 7, we get this, right? Same answer. But if the hydrogen ion concentration is greater than this, then it's acidic. If it's equal to this, it's neutral, and if it's less than this, it's basic. Litmus color indicators, I think you've dealt with indicators before. I'm not really concerned about indicators today, but what is acidic, basic, or neutral? I usually look at just pH. That's how I would find that, okay? So here's a couple that we'll do. You have a solution of hydrochloric acid with a pH of 3.4. What are the hydrogen ion concentration? What's the pOH? And what's the hydroxide ion concentration? Do it now. All right, so here's our formulas, right, that we talked about. And all we know is we have a pH of 3.4. And we are trying to find pOH, hydrogen ion concentration, and hydroxide ion concentration. And to do that, I just refer to what I know. Now, since I know the pH, and I know that pH plus pOH equals 14, finding pOH is pretty simple. So I use this formula, pH plus pOH equals 14. I substitute 3.4 in for pH. Subtract 3.4 from each side, and I have pOH. So I'm going to my calculator, 14 minus 3.4 equals, and you could see right there, 10.6. So my pOH is 10.6. Now, to find my hydrogen ion concentration, I take the base 10 of the negative pH. So hydrogen ion concentration equals 10 the negative pH. My pH is 3.4, so my hydrogen ion concentration is equal 10 to negative 3.4. And I'm going to set this up so you can see it. On this calculator, obviously you hit the base 10 button, right? And you go to the negative 34 or 3.4. So it looks like this, 10 to the negative 3.4, and there's my answer. So my answer of hydrogen ion concentration, 0.00398. I went 3 sig figs. I go get away with 2, but I'm going to go 3 just for this purpose. If I want to write this in scientific notation, it's 3 times 98 times 10, 1, 2, 3, 4, to the negative 4 molar. Okay, either answer is sufficient, but I'll put it in scientific notation. So there's the hydrogen ion concentration. Now, 2 ways to get hydroxide ion concentration. I could do this, where I take base 10 of the negative pOH, like we just did, or I can use Kw. I'm going to use this because it's different. Kw is 1 times 10 to the negative 14. That's equal to my hydrogen ion concentration, which is 3.98 times 10 to the negative 4 times my hydroxide ion concentration. So I want to solve for this. I just divide by 3.98 times 10 to the negative 4. And that should get me there. So I go 1 exponent, negative 14, divided by 3.98, exponent, negative 4. And I get this. So here's what my calculator looks like, right? 1e negative 14 divided by 3.98 e negative 4, and then I get my answer, 2.51 times 10 to the negative 11. So my hydroxide ion concentration is 2.51 times 10 to the negative 11. So I've checked all the boxes. You have a 0.78 molar solution of NaOH. Calculate the pH, the pOH, and the hydroxide ion concentration. Do it now. Okay, so we have a 0.78 molar solution of NaOH. We want to know the pH, pOH, and hydrogen ion concentration. First off, when I see this, OH, that means I'm talking about hydroxide. So my concentration of hydroxide is just going to be that. So I know my hydroxide ion concentration. Knowing that means if I want to find my pOH, pOH is negative log of that, so I take the negative log of 0.78. So again, calculator here, negative log 0.78, and that's what that should look like on your calculator. Negative log 0.78, and you get that. And so your pOH is 0.108. I think we're okay with sig figs there. So there's my pOH. All right, so there's the pOH. pH then plus pOH equals 14. So pH plus pOH equals 14. If my pOH is 0.108, that equals 14. What is the pH? Subtract 0.108 from each side. My pH equals T minus 0.108. My pH is 13.9. So I have pH and I have pOH. And then I want to find the hydrogen ion concentration. The hydrogen ion concentration, I'll find it this way. I found it this way earlier in the video, so let's find this one. Hydrogen ion concentration is 10 to the negative pH, 10 to the negative 13.9. So we find the 10 button, negative 13.9, hit equal. And that's what that looks like on the calculator. And then I get an answer of 1.26 times 10 to the negative 14. And that's molarity. So there's the concentration of hydrogen, there's the concentration of hydroxide. If I were to multiply those two numbers together, I should get Kw. And then here's a chart, and I'll put the chart on the board and show you how we can quickly fill out the chart. And part of the chart is deciding if something's acidic, basic, or neutral. Do it now. All right, so and how the chart's filled out works the same way as what we just did. I just wanted you to see it in a chart form. So if we know something, then we start to work our way through. So if we know hydrogen ion concentration, we can find pH. So let's do that first, right? pH is the negative log of 4.5 times 10 to the negative 6. And I'll show you what that looks like in the calculator. Negative log 4.5 e negative 6. I get that. So there's what it looks like on the calculator. pH is then 5.3. So there's 5.3. pOH, again, the easiest one's this one. pH plus pOH equals 14. Our pH is 5.3, so 5.3 plus pOH equals 14. Subtract 5.3 from each side. pOH is equal to 14 minus 5.3, 8.7. So our pOH is 8.7. To find our hydroxide ion concentration, I'm going to use this, Kw. So 1.0 times 10 to the negative 14 is equal to this multiplied by this. I'm solving for this, so I know what this is, right? Because that was given to me at the beginning. Hydrogen ion concentration is this, 4.5 times 10 to the negative 6. Divide by 4.5 times 10 to the negative 6 on each side. My hydroxide ion concentration then is 1e negative 14 divided by 4.5 e negative 6. And I get this really, really small number. If you put your mode in scientific notation on your calculator, which you could do here, right, then your number will be in scientific notation. And you'll get, I'm going to keep it in scientific notation, 2.2 times 10 to the negative 9 molar. And that would go there. To find if something's acidic, basic, or neutral, look at pH. pH less than 7, acidic. All right? You guys do B, all right? And I'll pause the video, put your answers for pH, hydrogen ion concentration, pOH, and if it's acidic, basic, or neutral. Put all 4 answers in there, right? So answer for this one, comma, answer this one, comma, answer this one, comma, answer this one. And then check yourself. If you're getting it right, you're good to go. If not, see me and we can figure it out.